Welcome to Hex-Cube map generation visual scripting using Unode Part 1. The requirements is Unity 2020.2.4, Unode 2.04, Probuilder to create the models, and we'll integrate Lean Tween later on. We are going to create hex and square models. We'll start a GameBoard manager, generate a basic hex map, and all this using Unode C Class functionality. Here we're starting to create the cubes, hexes. We're going to create both a pointy hex and a flat-topped hex, and we'll be able to accommodate those in code using the bounding functionality. So it doesn't matter what size they are. They can be both big or small, doesn't matter. Let's make sure we name the hexes and the cube or tile accordingly. So this one will be a flat hex, the next one will be a pointy hex. Then what we're going to do is make prefabs out of them. We probably will come back and modify those later. This is just quick and dirty, getting them set up and ready to rock and roll. This is not really a tutorial for Probuilder, so my assumption is you know how to use Probuilder to create things. So if not, go find a Probuilder tutorial. So now we have our prefabs created. We're going to kind of zero out all of the values, so everything starts at 0. Alright, good. Now that we have those created, we're going to go ahead and create a Unode component. Let's go ahead and right-click on the hierarchy, select Unode, and then select a C# component. In this particular case, we're going to be mono behavior, so go ahead and select mono behavior, and then go ahead and type in a namespace if you want. I always use a namespace so I can easily reference my own scripts. It's probably a good idea so you don't get any conflicts as well. Go ahead and save it. Call it Game Manager. That should save into the hierarchy there. And go ahead and open it up using the button that Unode provides. Once it's open, you'll notice that there's a few areas that we probably need to update, like the summary, what this does if you so desire. We want to make sure we name it the same as the prefab that was created, so in this particular case, Game Manager. I typically turn off the debug and then immediately compile, so the C# script is generated. And you see it takes a bit to compile, and there's a number of load buttons, so I will try and cut those out in the future. Alright, now we'll go ahead and create the methods and variables to start the game board. In this particular case, we will need a start method, so click on the little plus button and select the Unity and then start. Alright, so it's time to add a few variables. We're going to go ahead and click the plus button to add variables. We'll select integer for the first two. We will need a couple of booleans, a couple of floats, and a couple of integers. So here's the two integers. We're going to go ahead and add a game object for the tile game object as well. And then a couple of booleans for the width. So you can rename these by right-clicking and selecting rename, or double-clicking. So the game object will be named tile.go for tile game object. We will name the boolean is hex. This will determine if it's a hex or a cube or square. Then we will also want to set up a couple of integers, so we'll get the grid in tiles, grid width in tiles, and grid height in tiles. So we'll select those and set those up. Then we're going to go ahead and add 2 additional floats, and these will be used for the bounding of the tiles themselves. So this one will be tile width, and the next one will be tile height. Again, I like to organize my variables so they're all together and grouped with likewise variables. So my booleans will be at the top. We'll go ahead and create another one, is pointy, so that will determine if the hex is a pointy or a flat top. So here I'm going to go ahead and lock the C# script on the right hand side so we can see the code as we start to work through this. I also want to add an attribute to the variable so you can kind of see how to do that. And so here you press the plus button, you can type in the attribute name. In this particular case it'll be a tooltip, and we're going to go ahead and type in what that tooltip name should reference, or what you want the tooltip to be. Here we'll also go ahead and add a header as an attribute as well. This will create a bold header in the inspector once you drag and drop the script onto the game object. Here we'll go ahead and compile, see what that looks like in code. Should look pretty good. And we lock that so it'll pop up. Yep, there it is. I'm going to go ahead and rename a couple of these variables real quick just to, be consistent with all lowercase. Just start all the variables with lowercase. And all the methods will start with uppercase. Alright, we'll go ahead and create the methods that we're going to need. So first one is going to be set tile size. And then we're going to go ahead and create a few more. The next one is going to be set tile gap. Might be just easier to click, click, click. And then rename after we're done here. So we'll add a few. And this one will be set tile gap. The next one will be calculate initial position. Calculate world coordinates. And then the last one will be create grid. Set tile gap will be used to create a gap between the tiles if we want. Go ahead and compile this to see make sure everything looks good. And it does. We are going to go ahead and begin with the start method. So go ahead and click on the start method and center it so it's easier to see. Then we'll go ahead and drag in set tile size. We'll run that method first, and then we're going to go ahead and drag in set tile gap. That's the second method that we'll be running. So here we're going to do an if statement. So we want to make sure that the tile game object is not null. So we're going to go ahead and right click, add node, type in if, and then select the if from the drop down menu. We'll drag in the tile game object itself, and we'll select get. And what we want to do is make sure that's not equal to null. So we will go ahead and right click again, do add a node. Select that it does not equal, then you can go ahead and either type null or select it in from the top left menu there. So what we're going to do is, if this is true, we will create the tile grid. So we'll drag in the grid method, or create grid method, and if it's false, we're going to have a debug message. So we're going to go ahead and do debug.log, and then we're going to type in some kind of error message so that references that the game object is not set for the tile game object. So the next method we're going to go ahead and do is the set tile gap. So go ahead and select the set tile gap, and we will need to add an additional float variable here for the tile gap itself. So go ahead and call this one tile gap, and we'll go ahead and kind of start setting that up. So we're going to go ahead and have to set the tile width and tile height. So go ahead and drag the tile width and the tile height from the variable list into the canvas, and select the set And we'll connect those up. We'll go ahead and add a tooltip if you want, not necessarily required. This is just another example of how you would set up an attribute for a variable. So the tile width is just the tile width plus tile gap equals tile width. And the same with the height, right? Tile height plus tile gap equals tile height. So we'll go ahead and drag and drop in the tile width, set get. We'll select the addition. We'll plug that into the tile width setter, and we'll grab the tile gap, get it, and add those two together. And we're really going to do exactly the same thing for the tile height. And you can go backwards or forwards in terms of setting this up, whatever makes sense to you. I went ahead and grabbed it from the setter, found the addition, then I'll drag in the tile height and get it, and drag in the tile gap and get it, and then add those two together. Next, we're going to set the tile size, and this will be based on the bounding width and height of the tiles themselves. So here we're going to go ahead and drag in the tile width and set it. And we're going to drag in the tile height and set it. And what we're going to use is the tile game object, and we're going to get the mesh renderer, the renderer bounds, the bound size of the vector x and the vector y, or vector z, sorry. So here we grab the tile game object and drag it into the canvas. We'll get the game object get component mesh renderer. Then from the mesh renderer, you should be able to do the renderer bounds. You just type in bounds, probably the easiest way, and then you can get the size of that. And then you're going to get a vector 3 on the x. So now I have to line this up. My OCD takes effect here, so we want everything nice and neat and lined up. So give me a second here. Next thing we're going to go ahead and do once that's all lined up is do the set tile height. And it's basically the same thing. We can probably copy most of this and then just change the vector 3 to a z instead of an x. So there we go ahead and copy it. See if I can grab the right pieces there. There we go. And then we just need to type in vector 3.z. Plug that in. Next one we're going to do is calculate initial position. This one has some math involved, but basically we're going to set the start position, and we're going to have to return a position too. So this has to return something. And it's going to be a vector 3. So we'll go ahead and select the return type as a vector 3. We also need a local variable, and we'll call this one start position. It will also be a vector 3. There we go. Setting the start positions can be based on the tile width and the grid width in tiles, and then the tile height and the grid height in tiles. So we'll go ahead and grab the tile width from the variable list and drop it into the canvas. What we'll need to do is use the negate or the negative option here. See if I can find it. There it is. And what we're going to need to do is multiply that. So we'll grab the multiply option. There we go. And that'll be multiplied by the grid width in tiles. So we'll grab that as a get. And then we'll take that and then we'll divide that by 2. So we need to grab the division or divide node. Drag that into there and change that to 2. We'll add that to, so we'll grab that addition. And this will be plugged into a new vector 3's x-axis. So we're going to go ahead and grab a new vector 3 that shows all 3 x, y, and z. Let me select the new one. There we go. Oh, that's the new one, but it doesn't have the actual values that we need. So we'll go ahead and do that again. Select the third one down. There. Now we're going to go ahead and pump that into the x-axis. We'll need to add that, or finish the addition component. So what we'll need is a tile width divided by 2, and then plug that into the addition node. So let's go ahead and grab the tile width. Do a get. We'll do a division or divide. So we'll grab a divide node. Plug in a 2 there and connect it into the addition right there. There we go. Update that to 2. Now we've set the x parameter for the vector 3. We need to set the z parameter for the same. So we're going to go ahead and grab the grid height in tiles, and we're going to do some math with it and along with the tile height. So in this particular case, we're going to get grid height in tiles divided by 2, multiplied by tile height, subtracted tile height divided by 2, subtracted, and then, so anyways, see how I do it here. Grab the multiply. Multiply by tile height, and then all of that is subtracted tile height divided by 2, and then we'll plug that into a subtraction. So there's the subtraction component, and that'll actually be plugged into the z axis of the new vector 3. We'll go ahead and get the tile height, do a divide by 2, and we'll plug that into the subtraction, just like that. All this needs to be pumped into the start position of the local variable that we created earlier. So we're going to go ahead and drag and set that local variable, and then we're going to pump in this new vector 3 into that. So we need to kind of change these lines a little bit. There we go. The last thing we want to do for this method is to return the start position. So we're going to go ahead and link up the return, and then we'll plug in the start position directly to that return value. So let's see, so we'll go ahead and grab that, get it, and then link it. I'll go ahead and compile my code so we can see what the code looks like. I'll probably do that a little bit less later on, but for now, as we get used to it, we'll just compile and check code. Next one we'll go ahead and do is create grid. We'll skip the calculate world coordinates for now, and we'll come back to that. We will need a couple of local variables, tile grid game object, which is of type game object. We'll also need a tile game object, so we'll go ahead and create another one of type game object and call this one tile. Notice you can't double click on the local variable, so you do have to right click and select rename or use the top right hand section to rename it. We will also need a grid position, so we're going to go ahead and create a vector 3 called grid pos, or POS. Right, so the first thing we want to do when creating this method is we're going to go ahead and set the tile grid game object. This is going to actually get the tile grid itself as a game object. So we'll go ahead and drag that in, select set. Let's say this. And then you want to select the component game object and link them. Now what we're going to do is actually set the logic up to actually create the grid itself. So we will need grid height in tiles and grid width in tiles. We're going to do a for loop to pass through each one of those. So we'll go ahead and drag in 2 for loops here. One for the grid height in tiles and another for loop for the grid width in tiles. So there's our 2 for loops. We'll just link those together. We'll go ahead and get the grid height in tiles, and that will be our counter. And then we'll get the grid width in tiles, and that will be our counter for the second one. And basically iterating through each of the sets to create our length and width of our grid map itself. Here we're going to go ahead and set our tile. It's a local variable, so drag and drop the local variable in and select set. And we're going to go ahead and use the tile game object and instantiate that and pass that in as the tile itself. So drag and drop the tile game object in, select get, link that to the object instantiate, and then we're going to plug that directly into the tile. So we're setting the tile to that new tile game object. Notice I grabbed the tile grid game object. Don't do that. Grab the tile game object itself. Now we're going to go ahead and set the grid position. So go ahead and drag the grid position in and set. The grid position will be a new vector 3. So we need to go ahead and grab the new vector 3, and then it will take the index information for each of the for loops into the X and Z axis. So there's the new vector 3. Then we'll go ahead and drag that index value down to, drag that down to Z, and then we'll drag the next one down to X. So make sure that the first for loop is going to Z and the second for loop is going to X. Well, now we're going to go ahead and set the transform position of the tile itself. So we'll go ahead and grab the tile local variable, do the transform, and then transform.position, and we'll set that. Right click and do set, add node set. I find it to be a little bit easier. Select transform position. It'll create 2 nodes for you. You can link them together like that. Notice that set transform position requires 2 input values. The second one there is a vector 3, so we need to get the grid position. Drag that in from the local variables. Get a get, and then we need to do the calculate world coordinates. We do need to make sure the calculate world coordinates has a return type of a vector 3. So we go change that real quick. Delete this guy. I don't think we can drag him in like that. Nope, we can't. So I think the calculate world coordinates will need both a return type and an input type. So we'll go ahead and put a parameter in here as a vector 3 as well. We need to click the plus button under parameters. I select the parameter type. You also give it a name. In this particular case, I'll use position or pause. There we go. Now we go back to create grid. We can drag that in. It will take an input there to position, and then we can feed that into the vector 3 on the set transform position. Next thing we want to do is parent all of the tiled game objects or the tiles that we create to the tile grid game object. So what we're going to do is set the parent of the tile to the tile game object itself. So we'll go ahead and grab the tile object, then we'll go do game object.transform, transform.parent, and we'll set that. There's the parent. There's the setter for the parent. Now we need to fill in the vector 3 for that set value, which will be the tile grid game object transform. So go ahead and grab the tile grid game object. Find the game object.transform and then feed that into that set value. We're getting an error below because the calculate world coordinates doesn't return a value at this point, so it's complaining. But next we will work on that method. So there we go. Select that just as a quick remediation of that error message. The return, set up the return value to a new vector 3. That should actually resolve the error that we're getting down below. Isn't really the right vector 3 that I wanted, so let me go ahead and grab the other one. We want the one with the 3 values there. There we go. We want all 3 because we'll be feeding some information into all 3 of those. The calculate world coordinates will have to take into account if it's a square, a flat hex, or a pointy hex, so there will be some logic in here regarding that. We will need to create a couple of local variables, initial position or initial pause, and that'll be a vector 2. We also need an offset, which will be a float. And then in here we'll go ahead and create an X value, which is a float, and a Z value, which is also a float. The first thing we're going to need to do in here is set the initial position, and that initial position will be from the calculate initial position method. So just drag and drop the initial calculate initial position method and then link it to init position setter. Then here we want to set the offset to 0. We probably could do this in the properties of the variable itself, but I want to make sure it gets set here. Then what we're going to do is do an if statement. So like if it's a hex versus if it's a square, if it's a pointy hex versus if it's a flat top hex. So we will need a little bit of logic here to decipher that. We will be adding a couple of if statements above this for the pointy and his hex, but first let's go ahead and work on this particular if statement, which is going to take in the grid position vector3.z, and if it's not equal, then we're going to do something. So let's go ahead and start constructing that. So first thing is we're going to go ahead and grab a not equals, and then we will use the mod or modulo option here. Let's see if we can find it. There we are. Kind of working backwards to see to kind of construct this, see how it works out. So we'll need the vector3.z. That will be plugged into the mod. The mod will be plugged into the does not equal. We'll have a 2 in here on the mod. So this is the logic for hexes in general. That position should actually be grid position. I'll have to change that. If this doesn't equal, then we'll have to correct the offset. So what we're doing is we're going to do is set the offset here, and that's the tile width divided by 2 is the tile offset. Now what we're going to do once that is finished, we're going to go ahead and set the X and Z values. So go ahead and drop in the X and set it, and go ahead and drop in the Z and set it, and we'll add the math behind each of those. We're going to go ahead and set the local init position, the vector3x. So go ahead and drag and drop the local variable init pos, get vector3x. We're going to add that to the offset. So find the addition. Add that to the offset like this. And then we're going to add all of that. So we'll grab the addition again. And that'll feed into the set value of X. But we do need to finish that second addition. That will be the grid position vector3x multiplied by tile width. So there's our multiply. There's our tile width. Now we need the grid position vector3x. Notice here I grabbed the position, and that will need to be changed to grid position at some point. I messed up in the video, and I'll have to come back and fix that. Now we need to go ahead and set the Z value. So we can set that Z. We can also link that to the return as well. So the z value is going to be initial position vector 3z minus the grid position vector 3 multiplied by the tile height times. So some math here involved. So go ahead and drag in the init position, do a get. We'll get that vector 3z, and then we'll subtract that. So we'll get the subtract. Again, here we need to select grid position. I think the video is again wrong, and we'll have to fix that later on. But we're going to feed in the grid position to a vector 3z, and we're going to multiply that by tile height. We're going to go ahead and multiply that by 0.75 and then feed that into the subtraction right above it. So go ahead and select multiply. And not that one, of course, it's the other one. There we go. Feed that into the subtraction, and we need to make sure we put 0.75 here. The local x and local z variables that we have will be fed into the new vector 3 return statement. So go ahead and drag and drop the x get and z get, and go ahead and feed that into the new vector 3 at the very bottom. And that'll obviously be pushed into the return value. Given that we're getting the bounds of the tile height and tile width, we can set those to private so they don't show up in the inspector. And then what we can also do is add some notes or regions to help clarify what's going on. Here we'll add a region to check, just to notify us that this is the area that we are checking to see if the game object is null. You can right click and select add region to do this. You can also select a color if you want. Here we can add a summary or notes for each of the methods if you want. This will help notate the code as we go along. We'll fill out some of the summary sections of each of the methods. This will translate into code, notes in the code itself, / description, basically, right? So we're going to go ahead and add a summary for each of the methods. This also holds true for each of the variables or values or nodes. There's a comment section similar to this summary box in the top right hand corner, and it will add notes to the code as well. Might as well go ahead and create, in the create grid method, we'll go ahead and create a region as well, so we can see where we're actually creating the grid map itself. So right click and select region. Then you can size this appropriately to encompass all of the nodes that pertain to creating the grid itself. So here we'll go ahead and create like a plane for our background. Then we'll create a game object for the game board itself. So let's go ahead and center this plane, make it big enough that it kind of encompasses the whole thing so we can kind of see the offset in colors. It's a little bit easier to see. We'll find a nice material that actually might work. There we go. Here's where I'm going to go ahead and export the models that we made earlier into game objects. I'm also going to change the colors of each of them so I can tell the difference when we create the map itself. So if it's pointy, it'll be a color. If it's flat hex, it'll be a different color. And if it's a square, it'll be yet a different color again. So in this particular case, we'll do green, red, and blue. I think that makes it a little bit easier. We'll update our prefabs accordingly. And we'll go ahead and create our game board and center that into the center of the map. Here we have to go back and fix the create grid. This was supposed to be a tile object, not a tile game grid game object. So we'll go ahead and remove that. We'll grab the correct one, which is the tile game object, and that will be instantiated. Go ahead and drag the game manager script onto the game board game object, and make sure that you put the pointy hex there and check mark the is hex, and we should get a game board, a bunch of hexes. Good. Now we can play around with that and see how big we can get it, but notice that only the pointy hexes will work, and we will work on the squares and flat tops in part 2.